Hi there. Today we're going to be factoring and solving polynomial equations. My first example is just a reminder of GCF, which is review from chapter 5. So find the GCF of 2x to the fourth plus 4x squared plus 8x to the third plus 4x. So remember, a GCF is something we can divide each and every term by, and it is in fact the greatest factor that we can divide it by. So if I look at 2, 4, 8, and 4, their greatest common factor is 2. And then each term does have some x's. The first one has 4, the second one has 2, the third one has 3, and the last one has 1. So the largest number of x's I could take from each of these is just 1, because this last term only has 1x. So the GCF of this polynomial is just 2x. So just a quick reminder, we will be using that concept later on. So I have two formulas I need you to write down. We have the sum of cubes and the difference of two cubes. And if you just want to follow along and write this down while I do, I will explain it after we finish. The sum of two cubes just says that any sum of two cubes, a and b, equals, when you factor it, a plus b times a squared minus ab plus b squared. So it's just a formula to help us factor the sum of two cubes. So there's a slightly different formula for the difference. So if I have a cubed minus b cubed, our formula changes just slightly. So it becomes a minus b times a squared plus ab plus b squared. So a and b are whatever numbers or variables or letters that they give us in the original problem. So I'm going to go ahead and take you through a few. So, example 2, I just want us to factor. So letter A, let's say, is x to the third plus 27. Well, it might not look exactly like this original formula, but we can change that. I know that 27 is the same as 3 cubed, so I can rewrite that as x cubed plus 3 cubed, which does make it look a lot more like that original sum of two cubes formula. So now I just need to plug in these values. So x is a and 3 is b. So I have a plus b, so x plus 3 times x squared minus ab is minus 3x plus b squared is plus 3 squared, which is 9. And that's it. So I'm just plugging in these values into the given formula. So let's try another one. If I have x to the third plus 125, and I want to factor it, I can rewrite this as x to the third plus 5 to the third, because 5 to the third is 125. So again, I'm just plugging these values into my formula. A plus b is x plus 5. Then I have a squared, which is x squared, minus a times b is 5x, plus b squared is 5 squared, which is 25. All right. So here's another one, but this one we're going to do the difference of two cubes. So if I have 8x to the third minus 1, and I want to rewrite this as a difference of two cubes, well, 2x to the third is the same as 8x cubed, because 2 to the third is 8, and then 1 to the third power is 1. So this one is just a little bit different. Remember, the difference of two cubes is a minus b. So in this case, a is 2x minus b times, so a squared is 2x squared, which is equal to 4x squared if we apply our exponent rules, plus ab is just 2x, plus b squared is 1. So our answer here is just 2x minus 1 times 4x squared plus 2x plus 1. So remember, we're just using these very important formulas, the sum of 2 cubes and the difference of 2 cubes. Oh, you know what? I didn't write 2 up here. I'm going to do that now. And we're just plugging in numbers. We might have to change the example to make it look like the sum or difference of 2 cubes, but we just then plug in for a and b. All right. So now I'm going to move in to example 3. And we're going to factor the polynomials by grouping. So we're doing exactly what it sounds like. So my first example is x to the third minus 2x squared minus 9x plus 18. I'm going to factor by grouping. So the first thing I need to do is group my terms. And then I'm going to find the GCF of each term. So my first one, I have x cubed minus 2x squared. So my GCF here is x squared, and I'm left with x minus 2. So then I have 9x plus 18. Well, I can pull out a 9 here, and since this 9 is negative, I end up with x minus 2. Because if I were to distribute this negative 9, I have negative 9x plus 18, which is exactly what they gave us in the original problem. So now, since I have grouped these two together, I can find another GCF. So here I have x squared times the quantity x minus 2 minus 9 times the quantity x minus 2. Well, here our new GCF is x minus 2, and what I have left is x squared minus 9. So these two numbers, oh, I didn't mean to do that. Let me get that highlighter. X squared minus 9 become our second binomial. So that's factoring by grouping. I'm going to give you a couple more examples. So let's look at another one. I've got x to the third minus x squared plus x minus 1. So again, the first step is to group these into two different binomials and pull out separate GCFs. So the greatest common factor between x to the third and x squared is x squared. So I have x minus 1. And then when it looks like there's no GCF, really 1 is the GCF, right? I could do 1 times x and 1 times 1. So I really am choosing 1 as the GCF. So now I pull out my new GCF, which is x minus 1. And my other binomial is the two numbers that are in front. So x squared plus 1. And I do want to go back to part A. I did forget the very last step. So you do have to make sure that your binomials are factored completely. I did forget that x squared minus 9 can be factored more. So if I'm going to rewrite it over here, so x minus 2 times x squared minus 9. And we just noticed that x squared minus 9 is the difference of squares. So we did this in chapter 5, so I'm not going to talk too much about it. But I do know that my two factors are going to be x plus 3 and x minus 3 because I'm using the difference of squares. So my answer really is x minus 2 times x plus 3 times x minus 3. I do apologize for looking over that at the beginning. All right, I'm just going to do one more example, and then I think you guys will be ready for class. So if I have 3x to the third minus 2x squared minus 9x plus 6. Again, I'm going to group my terms, and I'm going to pull out a GCF. So if I have 3x to the third minus 2x squared, my GCF is just x squared, and I'm left with 3x minus 2. And then between 9x plus 6, I'm really looking, both of my terms don't have an x, so I can't pull out an x, but I can pull out a 3 from both of these, and I'm left with 3x minus 2. So remember, just like in example 1, this 3 is negative, So the term in the middle does become negative. So now I have a new GCF. My new GCF is 3x minus 2. And I have x squared minus 3. And now x squared minus 3 cannot be factored anymore since 3 is not a perfect square. So my final answer is just this. So that's it for today. We first did a quick review of finding the GCF. We looked at the sum of two cubes and the difference of two cubes. We have those formulas ready, handy to go for in-class practice. And then we were just factoring polynomials by grouping. So if any of these things feel a little complicated for you, I do recommend that you rewatch that part of the video and make sure you have everything ready to go so you're ready for practice in class. See you then.